Hi everyone, this video is on question 6 of exercise 9H, and it's about finding the coordinates of the points of zero gradients, which just basically means differentiate and find the coordinates of the points when divide x is equal to 0. So it's basically all about solving an equation once we have found the derivative. And the reason this question is interesting is that this is in the context of implicit differentiation, and it has a slight difference to the normal differentiation questions that we differentiate and then set that to 0 and find the values of x, and then the corresponding y values to find the coordinates when the gradient is 0. But this one is slightly different, and you'll see in a minute. Okay, so we differentiate this implicit function. X differentiates to 2x, 4y squared differentiates to 8y, but we always write the dy dx term for the dependent variable. Minus 6x differentiates to minus 6, minus 16y differentiates to minus 16 dy dx, and 21 differentiates to 0. So now we can take a factor of dy dx. This is a very common step. Once we have found the derivative, then we take a factor of dy dx because we want the dy dx to be in terms of x and y. So dy dx times 8y minus 16 is equal to minus 2x plus 6. The next step is dividing the bracket on the left hand side, so that we have minus 2x plus 6 over 8y minus 16. Okay, now at this point we want to find when dy dx is equal to 0. So it's about solving this equation. Minus 2x plus 6 over 8y minus 16 is equal to 0. Now it just needs a simple cross multiplication, which gives us minus 2x plus 6 is equal to 0. And now solving this equation gives us the value of 3 for x. So this is the x coordinate of at least one of the points, because remember here says find the coordinates of points, so there is more than one point. But interestingly, when we got the value of 3 for x, that means all the points have x coordinate 3. Now it's all about finding the y coordinates. So how can we do that? So it's actually the same as the previous differentiation questions, because once we have found the x coordinates from dy dx, then we just substitute that into the main function, and that allows us to find the y coordinates. So in this case, we substitute 3 into this equation, and we are going to have 3 squared, then plus 4y squared, minus 6 times 3, and then minus 16y plus 21 is equal to 0. Now it's all about solving this equation. So 9 plus 4y squared minus 18 minus 16y plus 21 is equal to 0. So we have 4y squared minus 16y, and now simplifying the numbers, so we get 9 minus 18 is minus 9, and minus 9 21 is 12 is equal to 0. We can divide all the terms by 4, so we get this, and we can factorize to y minus 3 times y minus 1 is equal to 0, and we have two solutions. So either y is 3 or y is 1, where x is 1 in both cases. So sorry, x is actually 3, not 1, and the coordinates are 3 1 and 3 3. So yeah, it's, as you can see, almost the same as the usual differentiation questions. Sometimes there can be some variations because it's implicit differentiation, but the main idea is the same. Okay, so thank you for watching.